Should it be an else if here? Is that what's going on? Do I not have pressed? Oh, yeah, that's because pressed is a completely different thing. Yeah, that's why. It should be is key down. So in this context, it's is key pressed is like you've pressed the key for multiple frames. And what we want is key down. And these input things are things that I have created, that I understand. The input controller of like, okay, this is down, this is held. You know, is key down is basically if you've held down the button for more than one frame. Triggered is the first frame. Down is just if the button's down or down or up or whatever. It's all sorts of different things you want to do with controls. And then you've got the whole like if you hold down a key like the A key or something in a text editor and then it zips out a bunch of A's and everything else. Got to deal with all that sort of crap. Key down. Just how it is. So let's see the difference between a killed jump and a non-killed jump. Because that might help me actually land on some of those platforms. If you remember yesterday at the end, I was having trouble landing on stuff because I'm not as good with the controller as I am with the keyboard. So that's a non-killed jump. That's a killed jump, so I can... So that's just holding it down the whole time, and this is letting go. So I can just give it a little tap and get over just a little object. Excellent. That's what we wanted. It's a little bit floaty, but I'll just give that to like Adam and just be like, tune it. Do what you want. It also gives a nice like minimum jump height if you just like tap the button real quick. So we could like perfectly space these so it's like, dong, 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 dong. Alright, now let's make sure that the jump happens based on... We want an intent to jump inside of our controller. So what this needs to do is if we are in the air and we hold down the key, we want to jump. So we actually need to have a state variable here. It's going to be private bool wants to jump. And we're going to set that to false to start with. Yeah, exactly. That's why we're doing it. We can have all the spikes on the ceiling so Bitey can die. Horrible, horrible deaths. What is that one game? Like 1001 Spikes or something, where you get 1001 lives, and you're supposed to go through the entire game, and that's once you run out of lives, you're done. So what we want to do is basically we want to see, okay, if the key is triggered, and we're going to call movement, I think it's can jump, and if we cannot jump, we're going to say like, okay, well, M wants to, what did I call it? Wants to jump. We're going to set M wants to jump to true. Otherwise, we're going to jump. And the same thing here, when the A action is not down, we're going to say M wants to jump equals false. And we're going to say if the key is triggered or M wants to jump. So what this should do is basically if you hold down the A key while you're in the air, you'll jump as soon as you hit the ground, unless you release the A key. And the question there is if I should actually do that. That might be a little too sensitive, right? We might want a timer on that. So we want like... Well, I'm going to see how it feels first. Because it might be something where it's a little touchy. Like, if you jump in the air and you're like holding down the button, but you like release it and hit it again, and you're like holding it down, and then as soon as you hit the ground, you jump again. You're just like, what the fuck? I didn't really want to do that. Like, I just wanted to jump high. You know? But we don't really have that, so if you lifted up the button anyway, you're not unkilling your jump. So let's just see how it feels, and let's jump around and see if it makes any sort of sense in our brains as to what this is doing. Yes, it would. I need to set wants to jump to false. Right here. And that'll make it so if you actually were successfully able to jump, then, you know, you're going to have to trigger that A key again. Somebody's following along. That's right. Well, you don't... Yeah. Well, good. Yeah, there was none of this sort of stuff where you could like go on Twitch and see somebody, you know, programming stuff when I was going through college. I don't know if it helped or hurt, because a lot of the learning is just you have to go make all the mistakes to really learn it. But it might have been interesting to see a few things that you might have been able to absorb through osmosis. So if we hold it down, nothing happens. So if I... I feel like I'm jumping higher than I should. Like the can jump is... returning before I'm actually on the ground. There's definitely a jump cooldown that I need in there, because I do not like... It should only allow... It should only have, like, wants to jump for a very short amount of time. So it'd be like, you know... If we can't jump, then we're going to want to, like, set our jump timer. So let's get that timer in there real quick. And we're going to want to grab our time utils for this. So we're going to want... Maybe we should just use the get process time. That's probably what we want. We'll do it in a float, so it'll be like G jump. Grace period or something like that. Grace period. That's probably going to be like a 0.3 F, so 300 milliseconds should do it. And what we'll do is we'll do like jump countdown, jump grace countdown. And since we don't have to be absolutely precise with this thing, basically what we can do with our movement CC is just set this to 0 to start with, and we'll say like if m wants to jump equals false, then we set it to true, and we set our jump grace countdown to our period, and we do that. So we just do like if m wants to jump, we do like the jump grace countdown minus equals delta t, which we've got, and then like if this is less than or equal to 0, then we just say wants to jump is false. Timeout are wanting to jump. Well, I do attempt to explain things well. I think it's one of the biggest skills that an engineer can have is explaining things properly. Because a lot of the time you're explaining a very difficult concept to other engineers, and if you cannot effectively communicate with them, it's not going to work. So you'll find a lot of programmers, at least as far as in my experience, they'll use a lot of proper nouns for things instead of pronouns. So, you'll instead of saying, well, like, can you do the thing, they'll say, can you go to the store? Or they might say, can you go to, and then specific store, and things such as that. It's also something you'll find with people who are getting old, actually. They will use a lot more pronouns and non-specific language. It's something my parents are now doing. They're very big on, I need to use proper nouns for things, for everything. Trying to do it, and they've found it's actually structured their thinking quite a bit. Because, as far as I understand, in your brain, when you use a pronoun for something, you're just using a replacement for the actual thing in your mind as a shortcut. Because your mind has to go retrieve whatever that is, whatever that thing that you're thinking about is. Or it can just be like, well, that thing I am thinking about, you can go get that in your mind if we need to actually visualize what the hell it is. It's kind of like, I know where my keys are, and then I know exactly where my keys are. Alright, so that's... It's probably that I'm... Yeah, see, we are actually hitting the ground. So my perception of the jump being instant is probably because of the camera. Oh yeah, that's a lot smoother. And that's the sort of thing that really speedrunners love, is when you have something like, if you hold the button down before you land on something, you jump the exact frame that you hit the ground. That sort of thing is exactly what people like to see if they're wanting to very precisely navigate some terrain. And we're actually going to turn down the grace period because I think it's a little bit too long at 300 milliseconds. I have absolutely no idea what you can get away with in German versus English and vice versa. So, you may be entirely correct. And English language is just a lazy language where we all just, instead of saying what we mean, just kind of wave our hands and say things and stuff and like a lot. So let's take a look. Let me see. I think what we're gonna do is I'm kind of tuning stuff I probably shouldn't really need to be tuning right now, but I'm doing it anyway. Yeah, the grace period at 100 milliseconds is feeling good. I'm gonna bust out the gamepad. It didn't feel like the jump kill was strong enough, so I increased that by 30%, and we'll see what we can do. Yeah, and I mean, all programming is pretty much done in English as far as I understand. And then you have to like learn English to fly a plane and tons of that sort of stuff. And then research papers written in English. It's kind of like, damn. Really don't have an alternative to English for a lot of things. For better or for worse, we're stuck with it for a long ass time. It'd be very difficult not to use it. So let's take a look here. Let's bust out our gamepad and move our FatSec around. Let's see how it feels. Oh yeah, I'm doing a lot better with the gamepad now, moving around on these platforms now that there's a jump kill in there. Like, yeah, I wasn't able to do that yesterday. Like, you remember I couldn't hit these frickin' platforms to save my life? Like, I was making fun of myself for being so bad at games. I was like, fuck, I can't do anything. But here, I'm just like, bam, got it. No problem. Now we need like an air dash, so FatSec can look like the guy in Hollow Knight and just like freaking do all the awesome shit. And then you see how hard it was to get into that hole before, and now it's just like, oh well, I just jump into it, no problem. You know, because we got that minimum jump height. You're just like, oh, no problem. And we got the air dash straight up. Awesome. No. Oh, wait, what the fuck? Why did that happen? What? Okay. That is hilarious. So what's happening is Fatsack has fallen off the universe or something. There's a check here that says you're in the air, and it's moving Fatsack upwards. Because there's nothing to land on, I think. All right, we'll figure. Let's figure that out. That's pretty funny. Fatsack's like, nope, I'm not gonna fall off the world. You tried to do that to me yesterday. You pushed me off the world. I ain't having any of that bullshit today. No, sir. So we're sweeping in the move distance. Yeah, let's see. No falling down to your doom, Fatsack. So let's just move off and just see what the freak is going on here. We're not in the air. We're not in the air. Look at that. Alright, so we get our position. Our movement direction vector is so we're trying to go down. And we did not collide, so our current velocity is 0. So we didn't collide. Collision distance is greater than or equal to... What? Our collision distance is -1. Okay, so this should not be this right here. This should be if collision dot collided. So probably a few of our other checks are screwed up. Yes, this should be again collided. So the only two places where that happens. And that's how you get crazy, stupid physics crap. Is all of a sudden you encounter a situation that the programmer never encountered. Then you fly into the fucking ceiling. Like, how does that happen? It's cool. There's this one weird spot over in Pennsylvania where gravity doesn't exist. It's just, mystery spot. We don't know what happened there. Some say it was aliens. Some say it was the Yu-Yu. Yeah, alright. So let's go run off that edge real quick. No! Excellent. So, nailed it. Welcome you. Alright. Let's see. What do we need to do? We need to remove some of these debugging things. I'm just taking a look through, just removing a whole bunch of things that I don't really need. It looks pretty good. So let's take a look at what else I've got on my list. Yeah, so we want a maximum frame time for our objects to update. So basically what that means is when our frame time is too high, we're just going to clamp it to something. So, and the question I have is I might have already done that somewhere, I just need to actually use it. And that would have been inside of either the game mode or the game manager or something. So we got delta time tick. I'll just throw a breakpoint in there and see when it ticks. So basically what it'd be like you'll always run at an equivalent of like 10 frames per second, even if your actual frames per second is lower. So and that can prevent a lot of issues. You just want to globally clamp that if you can on everything, because weird crap happens. We're not even ticking our freaking Dashkin game manager? That's not true. That's not true at all. Our compilers come in and optimize this, haven't they? Yeah, our game manager tick is in there. So let's take a look up. And it looks like we're going all the way back into the Unreal update loop in order to actually do some of this work. So in the run tick group method, yeah, what is stat tick time? Okay, so we got run tick group, this is tick, it takes audio time is there, delta seconds and time dilation for that. So we do have delta seconds passed into uWorld, so the world ticks. And what I'm looking for here is any sort of clamping of delta t. Because what we want is, I would like to be able to clamp like the entirety of everything in one spot. Yeah, so we got this info, fix up delta seconds. What is info? Is a world settings? Let's go Google that real quick. Not seeing too much. So let's actually see if we can walk into this. Fix up delta seconds. There is a min undilated frame time and a max undilated frame time. And we got this clamp. And what is the max frame time? Max undilated frame time is 0.4. So that's 400 milliseconds for a frame. So that would be, we're clamping it. It's somewhere right above 2 frames per second. So it's like 2 to 3 frames per second clamp. I don't really want to clamp that low. I want to clamp at like 10 FPS. So is there a way to set max undilated frame time? It's not even in world settings. Is it in A-info? Where the frick is it? Like, let's go to world settings.h. So it is in world settings, and it is just set somewhere. Let's just Google how we set this thing. So you're supposed to set this inside of the editor itself, is what it's looking like. This is under settings, world settings. It's not opening world settings. Why wouldn't it open the world settings? We just literally cannot open world settings. Oh, there it is. It's on the right. I just can't see. So yeah, opening up world settings opens up this thing over on the right. And we've got it right here. So we'd want like a 0.1. And that's actually a setting on the map. That's not what I want. I want a setting that's not going to be map specific. So let's just see where this thing is used. No, it's the max undilated frame time, I believe. World settings, max global time dilation. No, I wanted to search for undilated frame time. There it is. So this is base game.ini. Alright, well, let's just pull that in. This is Project Dashkin engine config. So this is like a base config setting for Unreal 4. Here we go, we're gonna set it to 10 FPS. And 2000 FPS? Oh hell no. We are definitely clamping this at like 100 FPS or 120 FPS. So it should be 0.083? No, this is 4 milliseconds. 4 milliseconds would be, so what would 83 be? So like, yeah, that's 120 FPS. Sorry, that's fine. So that should be fine. We'll just go ahead and exit out of that. And the question is going to be if by changing those base settings that all of the maps fix themselves, or if we have to go through all the maps and fix them. Stupid maps. Simple enough. So the reason for that is I was getting that warning there with the max physics iterations getting knocked off because I've got it limited, so there's only so many iterations that happen on the physics engine with physics steps, regardless of what the hell you're doing. And when the frame rate turns real low, yeah, that sort of thing happens. Max physics iterations for object. So I would expect if we're doing 5 millisecond ticks with our physics stuff, we have 100 millisecond frames, so 10 FPS. We're gonna need quite a few iterations, aren't we? So the question would be, should I actually do the min physics, change the step time to like 10 milliseconds or something? Because at 5, or maybe we do something like 8 milliseconds. That seems reasonable. And then, what's the maximum? Is it 10? G max physics move iterations. I guess we'll do like a 20 on that. So 20 times 0.8. So what is 20 times 8? That's 160. So minimum, yes, that's going to be above our minimum frame time. So we can actually take that down to like 16, maybe. $128? Yeah, it should be fine. We'll just do that. So 16. So, fun times. One more button done. Yes, let's just double check that this actually does exactly what it should. Alright. So what are we doing? Yeah, we're just double checking. Yeah, so I'm not seeing any more physics iteration craziness, so yeah, we're good with that. We have now successfully clamped our stuff. But I should go double check that it actually works for the map. That I want to check, I'll check Adam's map and see if it actually does what we want. Yeah, people are talking to me on Facebook. So let's see. Let's go to Adam's map real quick. It's down here in test levels, prototype. Adam's mess. Gotta love that. And settings, world settings. And yeah, it did actually set it, so we're good to go. Excellent. So it worked. Yay! Alright. So that works pretty well. I'll just go to my volume mixer and just kill Chrome's audio so nobody can hear all the things on Facebook. Alright, so what else have I got on my list here? So maximum frame time is done. We got variable height based on the jump. We've cleaned up the physics code. So what we'd like to work on is on-wall movement for a character. So we want to basically be able to do two things. We want to be able to jump off of a wall, and we want to slide down a slope. So how do we do that? Yeah, it's like, where's all the beeping? Must turn it off. Yeah, I'm a little bit distracted at the moment because I'm bitching about stuff with other people on other forums. Talking about, exciting things such as sprint planning and all the awesomeness that goes along with that, which is always amazing and always fun. So, how should we do this? Let's do jumping off the wall first. So, how should we be able to determine if we are actually able to jump off of a wall. Yes, all the Mario dungeon music. It's amazing. So, the question should be, so for us to be on a wall and to jump, what is that going to mean? So, there's a couple ways we could do it. So, kind of like how Metroid and some of that works is, right, you press in this direction and you hit, like the A key, and, your dude jumps off the wall like that. And you can pretty much understand why that would be difficult in a programming way to get right. Like it's wall jumping is just a total pain in the ass for a lot of people who play Super Metroid, because I would assume as soon as you're not touching the wall, the physics code has no freaking clue that you're next to a wall, and so it's like, well, you're hitting A while you're in the air, so yeah, you have to hit the A button at exactly the time you hit the wall and crap like that. And that's probably kind of why it's the way it is. So would it be, if we want to wall jump, if you hold, should you have to hold the opposite direction? So like you're going towards a wall like this, and all of a sudden you're holding, your wanted velocity is in this direction, and you want to say like, can I jump? We basically take your dude, project him in the direction that you would have been going for the next frame time, and been like, well, can you actually get over there? In which case, what we would want to do is move you to that location or something, and then give you a velocity in that direction. Or would we want to, like, how close would you have to be to wall jump? Would you have to be like literally on the frickin' wall? Super close? Because if we actually simulate you going towards the wall, we need to actually subtract the DT that we moved you later. So you should be touching the wall to jump up. Well, then there's also the definition of like how close to a wall is touching a wall. Like if you are, if you're in a tunnel or something and you are right next to the wall, but you're falling straight down, does that mean you're touching the wall, right? Like, does that mean you could just jump right off of it? So the question would be more, if you're going to do a wall jump, should you still have to have positive Y velocity in order to actually jump off that wall? So you have to kind of be, does the normal to the wall have to be, opposite in the direction of your Y motion, and does your Z velocity have to be positive or 0 in order for you to actually execute a wall jump? So if you're falling straight down and you pressed it and your guy, like, how would he jump, right? I guess that's the other question, is if you're falling super fast and you jump, are you like kicking off the wall? Yeah, you can push off the wall while falling. Okay, so basically what we should do is, if you try to jump when you're on this, we're basically going to take your velocity and we're going to add a velocity away from the wall, and we're also going to add your current motion direction. So if you were moving downwards, like you were falling downwards and you hit a wall and you jumped off it, Bitey or whoever would actually jump faster down. He would like kick off going in the down direction. But if you're moving up, he's going to kick off going up. And there's a maximum, negative Z velocity that you'll be able to achieve, so it should be just fine. Yeah, we're just discussing all the things on Facebook about Scala versus Java and crap like that. And I don't know what the hell I'm talking about with Scala, so of course I'm just trash talking it, saying it's full of garbage. Which is not true. Alright, so our can jump is going to be just fine. So, and our want to jump is going to be all that stuff. So when we call jump, we're actually not going to be using a jump vector right here. Our jump vector just doesn't frickin' matter, right? Like, our jump vector is whatever the hell it wants. So we're just going to call jump, and we're going to give it a velocity. So we should get rid of this jump vector because it doesn't matter. We're not going to use it. We're just going to use our jump velocity. Or should we have both? Like, what the hell is the jump vector even doing for us? I would guess if you're going to be wall jumping off there, there's going to be an addition to it. You might want to lose velocity by pushing off the wall. Well, we've already got friction for hitting the wall and being on the wall. And there's definitely, we should have some tuning variables right there for how much velocity you get. So I think we can handle it with that. Let's go take a look at the jump and let's... Oh, hey, it's right here. Because our Z is basically just getting set at this point with our jump. So maybe we need to specifically do wall jump versus floor jump. And floor jump looks like we're always jumping straight up. I don't see any reason to not do that. So wall jump should be a very specific thing. So you call jump, and it'll just wall jump. So if we take away the direction for the jump, is there any reason whatsoever to keep it around? Like, is there any time I want to have a jump and give a velocity to something in a direction? And could I accomplish it other ways? I think just a normal jump probably would do it. So I think we'll just take this out. No, the direction's not a bad idea. We should actually be not passing in a direction though. We should be passing in our left or right, I think. Alright, let's take a look at this. I'm going super slow because I'm just talking to too many damn people. So we need a Dashkin direction. And basically this is going to be dir. And direction is going to be switch dir case. And dd left, dir equals left. So that's going to be f vector 0, -1, 0, break. +1. And yeah, let's just say if you don't specify, or if you're a DD none, then actually just screw it. DD none. You'll be facing right. No problem. These are others ain't pushing off the wall in that case. You're supposed to continue speed and jumping over. We'll see. Alright. I need to stop being so distracted. Alright, so we should do is if can jump. So basically what we're going to do is if we're on the ground, then what we want to do is return true. So it's like if we're on the ground, then return true. No, that's not true. If we're on the ground, we want to do this sweep in this direction. Otherwise, we're going to have to try to figure it out. And can jump, should we specify a direction when we're like, can we jump to the left or can we jump to the right? So be like, yeah, you can jump to the right when you're not. We're going to have to actually specify a direction, aren't we?